Hi everyone, thank you for joining us for our surprise bonus workshop in the Etherlink Hackathon. Today we're really excited to have the Etherlink team with us to deliver a technical deep dive workshop. So we're inviting Adebola, who is a DevRel at Trinitech, so working with the Etherlink team, to come and join me on stage. Hi, thank you for joining us.
Hey, Rebecca, thanks for having me. All right, cool. Amazing. It's good to be here. I'm excited for this hackathon as well. Super excited to have everyone. Sorry about the sound in the background. It's just some construction going on near my apartment. All right. Glad to have everyone here for this workshop. This is going to be more of a technical workshop. I think last week when we kind of kicked off this event, when we kicked off this hackathon, the Summer of Code, we kind of went through what Etherlink is, what the chain is about, kind of what everything about essentially, right? But this is going to be more of a technical walkthrough workshop. And we're going to write a very small smart contract very quickly, but just kind of give you a feeling, give you a taste of what you can do on Etherlink. And in today's workshop, I'm going to be focusing on real-world assets and kind of how they work and how to kind of put one on chain. So it's very simple smart contract to essentially put a real-world asset on chain. As Rebecca said, my name is Adebola. I am a developer relations engineer at Trinitech, and we're working on supporting and building on top of the Tezos blockchain. Now, what is Etherlink? Etherlink is an EVM-compatible rollup that is built on the Tezos Layer 1. So essentially, think about every good thing that comes out of Tezos Layer 1 essentially is inherited by Etherlink. So things like our consensus mechanism, our fraud proof, all of those good things that you get out of the Tezos Layer 1 out of the box, you also get on Etherlink out of the box as well. And with Etherlink, you can use any EVM-compatible tools that you're used to. So MetaMask, Remix IDE, Solidity, ThoughtWeb, Sequence, like any of these tools and languages that you're used to using on your EVM-compatible chains, you can also use on Etherlink. And what's beautiful about Etherlink is that it's fast. So confirmation time is about 500 milliseconds. So very quickly, transactions get confirmed on the chain, and data also gets posted to layer 1 in about 8 seconds. So once data is posted to layer 1, essentially means that data or that transaction cannot be reversed anymore. And it's quicker than Optimism and quicker than Arbitrum. And of course, it's also nearly free. Nearly free in the sense that transactions or gas fees typically cost about a fraction of a cent on top of Etherlink, so which means that your transactions are super cheap, allowing you to kind of do a lot of transactions on the Etherlink chain. And in today's tutorial or workshop, we're going to be talking about real-world assets. And I'm super excited about real-world assets, particularly if you were at the event in Cannes, Robinhood unveiled tokenized stocks, right? So if you wanted to buy private stocks like, like OpenAI or SpaceX, which are actually not publicly listed anywhere, Robinhood found a way to kind of tokenize these private assets and bring them on chain. But in today's workshop, we're going to be talking about real-world assets. And a great example of that is uranium.io. Uranium.io is actually built on top of the Etherlink blockchain. And what does uranium.io provide you? So uranium.io provides you an alternative asset class, right? So think about like gold, think about silver, think about treasury bills. So if you're someone who invests, think about private stocks as well. So if you're someone who invests today in some of these like alternative asset classes, and you're kind of looking to diversify your portfolio, open up yourself to kind of more asset classes, uranium might be a great place for you to start. And essentially, you can even sign up today. So if you go to uranium.io, you can actually start buying real-world uranium, or tokenized uranium on top of Etherlink, and start to earn from there, right? And it's also like super interesting as well. Something about uranium.io is that the physical uranium is actually, so it's physically backed. So the uranium that you're buying, the tokenized uranium that you're actually buying on Etherlink is physically backed. So the physical uranium is stored at a company's facilities called Cameco, and I think they're based out of Canada, right? So I don't know if you can go there to see the uranium, but if you actually wanted to kind of see the uranium, it's actually physically stored in a physical location. And if you're thinking about real-world assets, that's kind of how to think about them, right? So if it's a physical asset, most times that you can actually see and engage with in the real world, but it's backed by tokens that are on top of built on the blockchain. And also, this uranium that you buy from uranium.io is held in trust. For everyone who holds an XU308 token, that uranium is held in trust for you by a company called Arcax. And why would you want to tokenize a real-world asset, right? It makes ownership more accessible. So if you wanted to buy uranium today, you couldn't just like go to a store near you to buy uranium. You couldn't just make a call to a broker to buy uranium, right? Essentially, buying uranium is reserved for institutional investors and very, very large funds. And so if you and I wanted to get involved in trading uranium today or buying uranium today, we couldn't just essentially call somebody up to get that uranium. We would need to buy it. We can't access it because we would need to have a lot of liquidity to be able to buy uranium. But by fractionalizing the asset and tokenizing it, uranium.io makes it very, very accessible for anyone to own a piece of uranium. Also, another reason why you may want to tokenize a real-world asset is to increase liquidity as well. So for example, if you have an asset class, for example, uranium is a good example. You have an asset class that, you want a lot of people to be able to trade, buy, sell. You would use something like tokenizing that real-world asset to be able to get that. Just making sure that you guys can still hear me. We're good? Okay. Rebecca, can you just confirm that you guys can see me, please? Okay, cool. I see it in the chat. Thank you. All right, so let's talk a little bit about fractionalization versus tokenization, right? So in the last slide, I was talking about uranium and from buying uranium from uranium.io. Now imagine that uranium.io actually held 1,000 grams of uranium, right? And for every gram of uranium, they issue an XU308 token, right? And so so they would have to fractionalize that uranium for it to be more accessible to everyone. So let's say that $1,000 was something that people could not easily afford. Let's say it was like $1 million, right? You would want to kind of break down that uranium into fractions. So one XU308 token will represent like 1 out of 1,000 of the uranium, right? So you don't actually go cut up the uranium. You don't cut up the uranium rock. Essentially, you just kind of like create this digital version of the uranium on chain, and you fractionalize it. So you kind of break it down into like different units that people can own. So that's what fractionalization is. And tokenization essentially is representing that valuable asset on chain with a digital token. So in the case of uranium, XU308 is the token name of uranium, right? And so if you say, hey, like I own some uranium, how do you prove that? You can prove that by showing that you own an XU308 token on the Etherlink blockchain. And what makes this super interesting is that if, for example, you bought 4 XU308 tokens today and they're worth $4, if next year the price of uranium goes up in the world and it becomes $2 for 1 gram of uranium, which means that essentially for the $4 that you paid today, it's now worth $8, right, in the next year. And so you can go ahead to sell your XU308 tokens and cash out from the market. But think about investing in uranium or investing in real-world assets and tokenizing them as an alternative asset class for people who want to get involved in investing in alternative assets. And in today's tutorial, I'm actually going to talk about my friend, Aisha. Now, Aisha is an award-winning artist, and her work is displayed in galleries in London. And assuming that she wanted to tokenize some of her art for her community, right? She's a fantastic, brilliant artist. And I'm like, hey, Aisha, I can call her up and be like, I think this particular photograph or this particular work that you've done is super interesting. And I think that we should tokenize that asset on chain so that people in your community can participate in buying some of your work. So let's say Aisha is selling her artwork for, I don't know, say $20,000, right? And I don't have that kind of money to go invest in her work, but I really like her work and I really want to support it. We can actually tokenize a picture or a piece of art from Aisha and allow everyone within our community to bring in like $5, $10 to own a piece of that artwork. And then we can keep the artwork in the gallery, right? So if the artwork ever gets sold from the gallery, everyone who owns that Aisha token, so I'm going to call it the Aisha token, everyone who owns the Aisha token essentially also gets paid at the same time. If you want to learn more about Aisha's work, you can go to aishaseriki.com. I think we're also going to share these slides at the end of the call as well. So if you're super interested in the work that she's doing, go ahead and check it out. So why might we want to tokenize someone like Aisha's work? Like, why would we want to tokenize an artist's work? Sometimes art takes a long time to sell, right? But the creatives themselves need to continue to be able to fund the work that they're doing, right? And sometimes the art might be super expensive and not be accessible to everyone, but I want to be able to own a piece of art, right? So I can go ahead, tokenize that art so that people within my community can actually own a piece of that art. And at the same time, we can also have the custody of that art in a physical gallery while token holders hold the Aisha token. And this is one of the pictures that she took for one of our exhibitions. So super cool, black and white. Like I said, you can check it out if you want. And in today's workshop, we're going to be creating an Aisha token on Etherlink. The Aisha token is going to be an ERC20 token, which means that it's fungible. and it's transferable, so you can buy it, you can sell it, you can trade it. And then for Aisha herself, once we create this token, so the idea is that when you buy one Aisha token, you're going to need one XTZ. Now, XTZ or Tez is the native token of the Tezos blockchain, right? So if I send one Tez to the contract is going to give me one Aisha token back, right? And that way, if I decide to sell my Aisha token someday, I can also get Tez back, right? And then for Aisha herself, within our smart contract, so let's say after a certain period of time, Aisha is like, hey, I want to collect all the Tez that I've raised or all the XTZ that I've raised. Aisha can simply call the withdraw function on that smart contract to withdraw the XTZ that the contract has collected on our behalf. So what do we need? What are we going to need to do this technical workshop or to build this smart contract? First, we're going to need the MetaMask wallet, right? So with MetaMask, essentially it's a wallet. We can store some of our Aisha tokens in there. We can store some of our XTZ tokens in there. We can store some Ethereum, we can store some Bitcoin. It's simply just a wallet that just holds your funds. We're also going to need a faucet as well, right? So when you're building smart contracts on top of any blockchain, like particularly on the Etherlink blockchain, you're going to need to get some test tokens for gas, right? So for every transaction that you write on chain, or for every time that you do transactions from the chain, you need to pay for gas, right? And to pay for gas, you're going to need XTZ, which is the native token of Tezos, and the Etherlink blockchain as well. And you're going to need a faucet, which gives you free XTZ tokens that you can use to pay for gas. And then we're finally going to need the Remix IDE. So Remix allows us to write Solidity code for writing and deploying our smart contracts. So it should be pretty simple. So the first thing that we need to do is to set up MetaMask, and that's what I'm going to get into here. So if you come into MetaMask, by default, MetaMask doesn't actually have the Etherlink chain listed, right? Particularly not the Etherlink testnet. So to list the Etherlink testnet within your MetaMask wallet, you need to click on this top left button. Now this is already done from my MetaMask, but for you to do this on yours, you probably see something like Ethereum mainnet as the main chain, but you can then switch, and to switch or to add a new network, I'm going to switch to testnet here. But to add a new network, you simply just go to add a custom network, and you put in a network name. So network name is going to be Etherlink testnet. You put in a default RPC URL, and all of that is here. So RPC URL is node.ghostnet.etherlink.com. Paste that in here. You can give it a name, so you can just say like Etherlink RPC. Add URL, and then we got the chain ID 128123. Copy that, paste it in here. Currency symbol, which is XTZ, and also the block explorer as well, which is over here. Now this is erroring out for me because I already have Etherlink testnet added to my list of networks on MetaMask, so it's not going to let me add this again. But essentially, if your MetaMask wallet is still fresh and you haven't done anything with it yet, you're going to need to essentially add the Etherlink testnet. And to get a MetaMask wallet, it's super simple. You can simply just search for MetaMask Chrome extension, come into the Chrome web store. This is going to tell you add to Chrome. Simply click on add to Chrome. And once you do that, it's going to be set up for you right here. So you can come to extensions, click on MetaMask, and you can get started with the MetaMask wallet. So super simple to do, super easy to do, and super straightforward as well. So that's how you set up MetaMask. And then the next thing that we need to do is to get some Tez or XTZ. And to get some Tez or XTZ, we need to go to faucet.etherlink.com. And that's open right here. So faucet.etherlink.com. If I connect my MetaMask wallet to this, click on I'm not a robot, you can see my balance is about 1240.146 Tez. So if I click on send, oh yeah, I claimed some tokens earlier today, so it's not letting me claim any more XTZ tokens. But if you ever run into this issue and you need some more tokens, some more test tokens, let me know. We can bridge over some tokens for you. And that's kind of a little bit more technical, but we'll get into that a little bit later. But if you ever need more tests and you're not able to get tests from here, just let us know in the Discord channel and we can sort you out. Okay, so finally, we need to write our smart contract. Now, our smart contract is simply going to do two things. So we're going to have two functions within our smart contract. One is going to be that you can actually buy the Aisha tokens. So one creates them. So every time someone sends XTZ to the contract, we can actually buy some Aisha tokens, right? So if I send one XTZ to the contract, I should be able to buy one Aisha token. And then also Aisha should be able to withdraw all of our XTZ tokens that have been contributed to buy a piece of art, right? So as an artist, as the owner of the work or as the collector of the work, say the contract is kind of on for a certain period of time. And Aisha is like, okay, I'm done selling this work now to everyone holding my Aisha tokens, and I actually want to withdraw some of these Tez. She can simply call the Tez function, the withdraw function, to withdraw some of the Tez from the smart contract. So yeah, time to do something super cool here. We are going to write the smart contract. So head over to Remix. Okay, this is one that I wrote earlier. Let me close this up. So head over to Remix. To get to Remix, simply go to remix.ethereum.org. And this is going to pull up the Remix IDE. Remix IDE essentially allows us to write smart contracts very simply. So I don't need to get into like VS Code, particularly if I'm writing like a very small smart contract. I actually don't need to spin up VS Code and start to import and install all of these modules and libraries. I can just come into Remix, which kind of gives me everything in the browser and out of the box, and allows me to write my smart contracts and deploy them very quickly. So I'm going to come into Remix. I've got my contracts tab here, and I'm going to create a new file. I'm going to call this Aisha2.sol. You can see I've got 1, I've got 0. All right, so now that we have this open, we're simply going to start up very quickly. I'm just going to copy and paste these parts of the code and just kind of talk through them as well. So first, we're telling Remix that we are requiring Solidity version 0.8.2 and above. And we're also importing these 2 modules as well, right? So we're importing these 2 modules of these 2 packages. One is the ERC20. Remember that the Aisha token is going to be an ERC20 token, which means that it's fungible. It can be transferred, it can be sold, it can be like you can move it around. Think about it as like a regular currency on top of the blockchain. So all of those currencies are fungible. They're ERC20 tokens, and the Aisha token is not going to be any different. Enable, this model gives us access control, so we can define things like who the owner of the contract is, who the owner of the funds is, essentially like anything that we want to, any function that we want only certain people to be able to access. The enable model on OpenZeppelin allows us to write things like that. So now we're going to get into writing the Aisha contract itself, right? So this contract, remember what it does, it's going to do two things. One is going to take in some XCZ. So let's say we have the buy function, and the buy function is going to accept some XCZ in return for Aisha tokens, right? So every time you send me 1 XCZ, I remember that here, it's going to be 1 XCZ is going to be directly equal to 1 Aisha token. Cool. And then we're going to have another function which is going to be called withdraw. And with the withdraw function, Aisha should be able to withdraw XCZ from the contract. And I hope you can follow along with this tutorial as well. I probably should have mentioned earlier that to follow along, you need some coding experience. And I also hope that if you're participating in this hackathon, there's probably someone on your team who's an engineer who has a little bit of coding experience. I mean, you can always depend on ChatGPT, but it's always good that you have someone on your team who's got a little bit of engineering experience as well. And we can also support you in writing some of your smart contracts too. So next thing we're going to do is now we're going to start to write our contract. So we're going to start out by saying contract. Oops. Contract Aisha is ERC20. We kind of explained that earlier, and it's also enable as well. So it inherits from these 2 classes. So the ERC20 class and the enable class. Cool. And then the next thing that we're going to say is that we're going to define a constructor. And we're going to say the address is going to be initial owner. And then we're going to define what that constructor should take. So it's going to take ERC20, and we're going to call it the Aisha add token. And we're also going to say it should be Aisha here as well, right? And then the owner of this contract or this token is going to be the initial owner. So whoever deploys this contract owns the contract essentially. And then we're just going to close this up here. And next, we're going to define a function. So this is going to be our first function that we're going to write, and this is going to be our buy function. So this function buy, external. So external here simply means that you can call this function from outside the smart contract, right? So there's certain times that you don't want people outside your smart contract to be able to call your function for security reasons. You would make this an internal function instead. So you can only call that function within your smart contract, right? But if you want people to be, if you want like your dApp, which is like a front end of your application, to be able to call this smart contract from within that application, or you want like a backend server to be able to call this contract, you need to make it external, right? So external, and then the next thing I will need to say is payable. So payable essentially means that it can accept funds in, right? So it can accept whatever the native token is, it accepts it. And the next thing we're going to do is we're going to say, so let me close this out here. Next thing we're going to do is we're going to require, right? So require is like an assert, message.value greater than 0. And if, so let's do this. And we'll say we must send XTZ to buy Aisha, right? So if you don't send any, if whoever is calling this contract only sends like, doesn't send any value, right? This is not going to work. So you need to send a certain amount of Tez, at least greater than 0, to be able to buy some Aisha. So you can't just call this, function within the smart contract with nothing. So you actually need to pass a value into this function. So close that up. And then once we've validated that there's an amount greater than 0 being passed to the buy function, the next thing we want to do is we want to mint some Aisha tokens, right? So we've gotten some XTZ in. The next step is to actually mint some Aisha tokens for the sender. So we're going to say message.sender, which is essentially the person that is calling this contract. And we're going to say message.value, right? Remember that one Aisha token gives you one XTZ. So if you call the contract with, say, 20 XTZ, you're going to get 20 Aisha tokens back. Now, of course, we can improve this contract by actually defining a maximum supply. So let's say we only want to sell about 1,000 XTZ worth of Aisha tokens. Rebecca, can you hear me? Good?
Yes, I can. I'm just jumping in. Could you zoom in slightly?
Oh, yes. My bad. Yeah.
Amazing. Perfect. Thank you.
Cool. All right. So if you've got, so essentially we can actually define like a max supply as well for this. So if we wanted only 1,000 Aisha tokens to be supplied and to be issued, we can actually define that in this contract. But we're not going to do that today. It's just going to be super simple. Whatever you send into the contract is essentially whatever number of Aisha tokens that you get out of the contract. So we're going to mint message.sender, message.value. So whatever, whoever is sending the request to the contract gets a certain amount of Aisha tokens. Okay, cool. So that's done. And then we can also write our withdraw function as well. So function withdraw. And in our withdraw function, we want it to take an integer and can be called as well externally. And we want it to only be called by the owner of this contract. Shout out to AI for suggesting all the code for me. So the first thing we're going to write here is we're going to say require, right, address. And we want to make sure that the balance in this contract is actually greater than, or like, whatever amount you're calling, whatever amount you're requesting for, is actually valid, right? So if you call this contract and say you want to withdraw, say I actually wanted to withdraw, 5,000 Tez, but the contract only had, say, 5 Tez in it, this should fail, right? So it should return insufficient balance. And if everything is fine, simply send the amount back to the owner in XTZ. Yeah, so that's pretty much our contract written up. Super simple, super straightforward contract, and can actually test if everything works. So I'm going to click on compile here. And so when I click on compile, so if you look to my left, you can see that it says compilation successful. We've got a green tick here, which means that everything is fine. We can actually go ahead to deploy this contract. So I'm going to go to deploy and run transactions here. And the very important, you need to switch your environment to the Etherlink testnet. So I'm going to click on Remix VM Prague, and I'm going to switch to injected provider. So I've connected this already, but on your own side, if you're going to be using Remix, make sure to also switch to the injected provider as well and click on MetaMask. So I'm going to click on this, and now you can see it's switched over to the Etherlink testnet network. This is my wallet address that is already connected. Also shows my wallet balance as well, which is about 1240 Tez. So if I come in here, we should probably see the same thing as well. Let me see. Does it show me how much Tez I've got? Yeah, for some reason it doesn't show me in Tez. Anyway, so back to Remix. let's try to deploy this contract to the chain. I'd like to switch this to Ether. We've got this. I'm going to copy my account here because to deploy this contract, we need to state who the initial owner is, right? And the reason for that is because in here, we say only the owner can withdraw, right? And only the owner actually like has permission to distribute those tokens. So we need to define who the initial owner is, and I'm going to use my wallet address to define who that initial owner is. And I'm going to click deploy. So this is going to tell me to confirm, and I'm going to confirm, and this is deploying. All right, so if you can see my terminal here, maybe I should zoom in on the terminal instead. Let me see. All right, cool. I think this should be visible enough. Right, so I can click on view on Block Scout, and that is going to pop open the Explorer. Now to access the Explorer, simply go to testnet.explorer.etherlink.com. All of this is also in our documentation as well. So if you go to docs.etherlink.com, you're going to be able to access all of the, the RPC nodes, things like that, the Explorer, the faucet. You'd have all of those links listed in there. I'm also going to share a copy of this presentation at the end. So if you want to find that information in there as well, you can go ahead to find that in there. So as you can see, we have successfully deployed our smart contract. And if I click on this link here, this should actually show me the contract itself. Cool. And if I click on transactions, you can see contract creation was a success. So yeah, everything looks good so far. So next thing that we need to do now, let's actually test this out. Let's test this out. Let me zoom out a little bit. So to play around with your contract and you're on Remix, simply under deployed contracts, click next to Aisha, which is what I deployed here. You can see, it's showing ETH right now, but it's going to be XTZ. So let's say I want to send some tokens to the contract to actually buy the Aisha tokens. I can simply come in here and say I want to send 100 XTZ. This is Ether, but we're working with XTZ here. So 100 XTZ, and I am going to buy. I'm going to click buy. So let's see. So I'm sending 100 XTZ. Network fee is about, you can see it's a fraction of a cent, right? I'm going to click confirm. Cool. So that transaction went through. I just bought some Aisha tokens, and I can actually, so if I click on view on Block Scout, I can see what I bought. So you can see Aisha token was transferred from this address to my wallet address, which ends in FA9D, and I got myself some Aisha tokens. So if I come back into MetaMask, see I lost some money already from my MetaMask wallet because I just spent 100 XTZ buying some Aisha tokens. Whoop, whoop, I'm supporting my friend. And so if I wanted to add this token, so here you can, oh yes, so here we go. So you can see the amount of XTZ I've got here. You can also see some USDC tokens that I've got here, but I can actually add some Aisha tokens here as well. So I can simply I can click on these three dots here, click import tokens, select a network. I'm going to use the Etherlink testnet, which is where we deploy the Aisha tokens to. So the testnet is like a development environment, and that's where I've sent the Etherlink. That's where I'm deploying this contract to. Then the contract address. So let's pull up that contract address. I think it's, let me try to find it. Oh, yeah, there we go. This is our contract address. Let me just confirm that from Remix. Yeah, okay, yes. This is it. So this is what we need. This is our contract address here. I can go back into MetaMask now, and I can paste the contract address. And you can see it already picks up the symbol. So if you come back to Remix here, you can see that when we created this token, we defined it as ASHA, or like Aisha for short, right? And now if I come into MetaMask, MetaMask already knows that this is an Aisha token because it's already picked it up from the Explorer. So if I click next, you see we just bought 100 Aisha tokens, and you can see MetaMask actually recognizes that we've got 100 of them, and can simply click import, and that's going to show up as 100 Aisha tokens. And I can do that again. Like, so if I wanted to actually buy some more tokens, I can do the same thing. So I can come up here and say, let's say 20, right? And I can click buy again. Same thing, confirm. Cool. So we just bought some more. So let me see if this, let's see. Yeah, here we go. So you can see that. So I bought 100 before. Now I've got 120 Aisha tokens. You can see how quick the transaction was. Super quick, super fast. And that shows it up there. Yeah, I think this is pretty much it, right? So very simple, very easy to deploy a smart contract on Etherlink. Essentially, you're just using Solidity, which is if you've ever written smart contracts for the blockchain before, you have written Solidity before, particularly if you are deployed on EVM chains. And like I said, you can use any of your EVM tooling to deploy contracts on top of the Etherlink blockchain. So if you've got any questions, if you need any help with writing your smart contract, with integration of your smart contract with your front-end application, which you can do with ThoughtWeb or Sequence or any of our partners that we've listed for you, please reach out on the Discord channel or send me a DM on Discord and I'll make sure to respond to you. Yeah, that's pretty much it from me. I think it was pretty quick and I hope you were able to gain some value from that. So I'm going to stop sharing my screen for now and I would allow time for any questions if there are any.
Thank you so much, Ademola. That was a really, really good introduction.
Rebecca, I can't make out what you're saying. You're kind of cutting out.
Oh, interesting.
Yeah. Probably the AirPods.
Yeah.
Do I sound better now?
Yeah, it's much better. Much better.
Okay, amazing. Yeah, my sound went a bit weird as well. Yeah, it was connected to my headphones. Thank you very much. Is what I was saying for delivering that workshop. It was a really great introduction, and for those who were unsure about how they could get started, I'm sure they're now certain, and that's going to be a great resource as well for those who weren't able to make it live when the recording is posted tomorrow. We've just got a question in chat there, which you can see. I'm going to read for the recording. You were using Remix when you did that tutorial. If you wanted to build a full stack app, can you use Remix, or do you recommend using something like VS Code?
So I would say it kind of depends on what you're trying to do, right? Personally, I really like to kind of separate, sometimes I like to separate whatever I'm building. So I may use like Remix for like my smart contract, right? Make sure I can write my smart contract, make sure that the contract actually works, right? And I can interact with it on Remix. And I can test all of that very quickly without going into VS Code and having to like set up an environment, set up like different tooling, set up different things. I can simply just write it on Remix, which has everything I need, deploy it, test it out, make sure that it actually works, and then go write like my front end and my back end, something like Next.js or in React or in VS Code, right? And then just simply like make RPC calls to the network.
That's some great advice, hopefully useful for anyone getting started building full stack apps. It is all down to personal preference. So you could also test out different ways and see which way works best for you. We have another question. You mentioned front end applications. Can you explain a bit more what you mean by that?
Okay.
Is there no need to create them?
Let me see if I can show a quick example here. Okay, let me. Cool. So let me share my screen here. So I'm going to show an example that doesn't actually work, but I will explain why it doesn't work in a second. Cool. So like I just showed you guys, I essentially showed you guys like the back end of my smart contract, which is you can swap some XTZ and get some Aisha tokens out of it. And this is what the front end of the application could possibly look like, right? And now I'm going to be able to click buy to buy some Aisha. I'm going to be able to click sell to sell some Aisha tokens. And I'm going to be able to click send if I want to send them to my friends. So if I have some Aisha tokens, but I want to send them to my friends, I can simply click send within my front end. And that would essentially execute those transactions on the chain, right? And like I said earlier, you can use something like ThoughtWeb, which is one of our partners, to kind of to manage all of these parts of integrating with your smart contract, right? So if you have a simple front-end application like this, but you want to actually integrate or make calls to your smart contract. So you can use something like ThoughtWeb that makes it really easy and has like a lot of abstraction as well that allows you to achieve that. I hope that answers your question.
I think it should do, but Chidinma, if it didn't, please put a follow-up in the chat. regarding the question about recordings, I can answer that. The recordings for previous workshops are being uploaded and made public. Well, actually, I say that they're not public, they're unlisted, meaning you can only access them through the link. The links are currently in the Discord, meaning that if you go into the README channel in the Summer of Code specific hackathon channel within our Discord, you'll find all the recordings posted there up until Tuesday's workshop, I believe. So the launch Monday and Tuesday, yesterday's workshop and today's will be posted tomorrow. So you can always get them from there. The next question was about bridging assets. So you kind of mentioned earlier, Adebola, but this person has asked, it's great that it looks like it's development on an EVM chain. They're asking, what about bridging assets? Is there something about programmatically providing testnet funds for users?
Okay, to do it programmatically, I'll need to look into that for you. But if you just want to do it, I don't know if we have APIs for that actually. I'll need to check. But if you just, especially if you just want to do it by yourself, right, from the UI, simply go to testnet.bridge.etherlink.com/Tezos. That's a super long URL, but
it's very convoluted.
If you go to our docs, so just docs.etherlink.com and just search for bridge, you'll be able to find a bridge there. And this is, can you see my screen?
Yeah, we can.
So if you can see my screen right now, this is the bridge UI. And you can bridge from, so let's say, hold on. So if I wanted to do EVM bridge, here we go. So if I wanted to bridge, so you can see I can bridge like USDC, I can bridge SOGNI on Base, I can bridge wrap BTC, right? So there are a couple of tokens that I can bridge here, and I can bridge them into Etherlink, right? So if you wanted to do that, you can simply go to the UI to do that. Do we have it programmatically yet? I don't know. I'll need to check if we have APIs to do that.
And to follow up on that, maybe if you could put a message in Discord so that Palash, if you just keep an eye, then maybe you can get an answer there. I think this is, Palash is talking about his idea. One of the options is I can deploy a faucet contract for my users, but I would need to fund my contract. The main idea is I don't want to make my users leave my app, and ideally everything can be done within the modal.
Yeah, that's fantastic. I feel like you're technical, so I'm going to give you this answer, and I think this should help you. So you can see that the faucet itself actually only gives about 15 like micro TES. But if you wanted to get like thousands of TES, right? What I would do is to go to let me paste the link in here, and you can also message me on Slack on Discord for this. So you can actually go to the actual Tezos faucet. What's it called now? Faucet. Okay, I can't find the link right now. Oh yeah, here we go. So let me paste this in here. So you can actually go to the Tezos faucet, get some actual XCZ on the Tezos layer 1 chain, and then you can bridge that over to Etherlink, right? So you can bridge that over to Etherlink, and then you can then kind of have that contract hold all that TES that you've got, and then allow your users to kind of like move back and forth between the TES.
Nice. So hopefully that's a good solution for you, Palash.
Yeah, and I think Boluwatife had a question as well. This is my first hackathon, and I started a bit late. Do you think I'm still able to attend? Yeah, of course.
Absolutely.
Who knows?
Maybe not started late at all.
Exactly. Maybe you could build something really amazing in one night, right? You've got like a lot of AI tooling as well. So you've got ChatGPT, you've got a number of AI tooling. So I'm pretty sure you can build something faster than you think you can.
Absolutely. To reassure you, you've not started late at all. The fact that you're in the live workshops means you're an early starter. People will start at hackathons at every stage of them. So never too late to start. This is your summer of code. Make the most of it and get started now because you're here now and clearly excited. Excited that so many people are having their first hackathon be the summer of code. That's really awesome. If you need any support, the place to be is Discord. We've got loads of mentors there. Adebola is there to support you on the technical side. And we have mentors who are in all walks of life in the company. So please reach out to all of them if you need support. And I hope that your first hackathons are great experiences. And for those who are returning hackers, I hope it's a great experience as well.
And I just put my Twitter handle as well. So it's Hey Adebola. So you can go ahead, follow me on Twitter, follow me on Instagram. I'm trying to get to 1,000 followers. So let's see if you guys can get me there.
Nice. Maybe drop it in Discord with a link. Sure. Make it get some fans from there as well. Okay, great stuff. This has been a really, really useful workshop, Adebola. Thank you for delivering it. And thank you everyone for your questions. I hope you also found it useful. The recording will be posted. So if you want to come and rewatch any of the steps that we've seen today, then you can do. We will end it here for today. We have one more workshop left in the Summer of Code workshop series, and then it's just hacking. So it's then down to you. Our workshop is on Monday at the same time as today's workshop started. So keep an eye out for the calendar invite for that. It's with the Gold Sky team. So if you're thinking you might need some indexing for your whatever project you end up building, then you can come along and learn how to index using Gold Sky. You also have credits available to you for the whole of the hackathon. So it's an amazing way to practice using some tooling that would otherwise cost you money to learn with. So a great opportunity there. Check out the Hacker Pack for everything that you need to know about the bounties, about the partners, about the mentors, about submissions. Everything should be answered there, and make sure that you're on the Discord so you're getting the announcements and you're up to date with everything that's going on. I will be in contact with you all as always. For those of you who've already had calls with me, it's been great to meet you and get to know a bit about what you're building and what your goals are. For those who haven't had a call with me yet, I'd love to chat. So please reply to my last email and maybe we can arrange a chance to meet. But otherwise, I will let everyone go. I hope you have a great rest of your day, rest of your week, until I see you again on Monday. Thank you, Adebola, for coming, and thank you everyone for joining us.
Bye, everyone. Bye-bye.